All right, so we're going to dive into law of sines, and what's important to know is that when it comes to congruency, we know from geometry that when I have two angles with the side between them, there's only one triangle that you can build, and those triangles will be congruent. And we learned in geometry that when you have angle, angle, side, an angle connected to an angle connected to a side, there's only one triangle that you can build, and it will be congruent to the original triangle. Now, when we get to ASS, which is the same as SSA, that was not a way to show congruency with triangles. So we're going to be looking at case scenarios where we have angle, side, angle, angling, angle, angle, side, or side, side, angle, and using that to find missing information about a triangle. All right, so I've drawn the triangle connecting L to M to N, and I've put in the key information, and we can see that we have angle, side, angle, which means that we're going to be able to build a triangle and it will be congruent to the original. So we're going to find all the missing information. So you've watched the video on law of sines and it's just proportions. So I'm going to set those up. So sine of 29 compared to its opposite side 22 is equal to sine of 112 compared to its opposite side. And then we have sine of n to its opposite side. Now we know that all three angles in a triangle have to add up to 180, so we can quickly determine that angle n is 39 degrees. So what we're going to do is we're going to just solve for the unknowns. So I'm going to have to solve for m, and I'm going to have to solve for n. And so we'll take this one proportion at a time. So m times sine of 29, using the cross product rule of proportions, is equal to 22 times sine of 112. And to solve for m, I'll divide each side by sine of 29. And then we'll use our calculator to solve for m. Excuse me. So we've solved for m and we get 42.1. So now when it comes to solving for n, I will just do the same thing using my proportion, this time using this one. Now you could have used sine of 29 over 22 with sine of n over m. I'm just choosing to use the two that I circled because they're next to each other. And we'll do the same setup using the proportion and go ahead and double check that, but we should get that side n is equal to 28.6. All right, in example 2, I've just redrawn this picture. And looking at the key information that's being provided, we have an angle connected to a side connected to an angle. So as we had discussed in geometry, that there will be one and only one type of triangle that you can build, and we're going to find the unknown angles and sides. So I want to start with angle C using the angle sum theorem, and angle C is going to end up being 50 degrees. So equals 50. So what we're going to do is we're going to set up those proportions using the law of sine. So we've set up our three proportions and we have two unknowns, A and B. So I'm going to set up a proportion solving for A. So A go, times sine of 50 has to equal 446 times sine of 58. Again, trying to solve for a, we'll divide by sine of 50. And we're going to get a is equal to 493.74. So that represents the distance from station B to the satellite. When you do the same thing, solving for the other proportion, you're going to get B is equal to 553.72. So very easy. If we have angle side angle, or we have angle angle side, we're going to use law of sines, set up proportions, and solve for any missing sides or angles. Now, when you know two sides and an angle, and the angle attaches to a side and connects to a side, or a side connects to a side, connects to an angle, this is what's called the ambiguous case. Now, ambiguous means something that isn't clear. So when we have this information, what this diagram is trying to show right here are all the different case scenarios that you can have. So what I'm going to do is really spell this out to what we're going to do step by step. But what we need to know is, are there two triangles, two different triangles that we can build? Is there one and only one triangle that we can build? Or is it not possible? Okay, so when you have ASS or SSA, we need to determine if there's two triangles, what would those measures of each of those triangles be? If there's only one, then we'll construct that and we'll find the unknowns. But it is possible where, based on the information, you just can't build a triangle. And we're going to take a look at each and every one of those case scenarios. So I've drawn the information for example 3a. We have an acute angle, 63 degrees, and we are angling up 25 units. Now, the 18 to form a triangle would have to kind of come down to this line AB somewhere. What we don't know is how from point C it connects down to B. So what I like to do is I like to draw in a dashed line right there, and I call that H. Now, I think you would agree that C could connect straight down to B, just we don't know. So that's always the first thing that I do when I have an acute angle, is I say, well, if H is 18, then C went straight down, and I'm only going to get one triangle. So again, I recommend that you watch the video on the ambiguous case. The video shows a nice job of how you can find two triangles. I'm going to see if there's one. So I'm going to just use trigonometry, and I'm going to solve for H. So sine of 63 is equal to the opposite, which is H, over the hypotenuse, which is 25. So the reason I call that H is that's the altitude or the height of the triangle. So H is going to give me 25 times sine of 63. Now, if I get 18, then it means that to get from C to the line AB, it's got to go straight down, not to angle down, but to go straight down. So I'm going to use my calculator, and I'm going to solve for H. And H ends up being 22.275. Now, what that means is, you'll remember this from geometry, that the distance, let me mark this, the distance from a point to a line, and I've got those points in orange, will always be perpendicular. So H ends up being 22.275. So in order for C to get to that line AB somewhere, it's 22.275 away. So when I look at this segment right there, there's no way that it can angle down that way because that would have to be a longer segment. So that's where I'd like to figure out what H is. In order for C to get to that line, it's got to be 22.275 units long, or in the case of angling from C to B, it could be longer than that, but they tell me that it's 18. So in this case scenario, there is no triangle possible. Now, if they had given me that third side, this one right here, was 22.275, there'd be one triangle that you could build. And from the video, we learned that if that third side is bigger than the 22.275, but smaller than the 25, that other side, then I can build two different triangles. So that's the outcome on 3A. All right, so in example B, I've drawn it, and we've got an obtuse angle. So there's that 105, and to get to angle C there at the top, I'm going 55 units from A to C, and then I notice from C to B is bigger than that. So I'm feeling really good about there being one and only one triangle that you can build. That side across from the 105 is bigger than what we have with that 55. So just dimensionally, it's looking like we're going to get one triangle that we can build. So we're going to use law of sines to solve for the unknowns. So here we go. So I've set up the proportion. Sine of angle A to its opposite side, 73, is going to equal sine of angle B to its opposite side, which is 55. So going through, let me set this one up. So I did the cross product rule. And what I want to do is I want to solve for sine of B. So this time I'm going to divide by 73 to each side. So we're going to get sine of B is equal to, so we get the 0.7277. So again, that's a good number to get for sine. We know that sine takes on ratios from -1 to 1. And so now to get the angle B, that's going to equal the inverse sine of that ratio. So angle B is approximately equal to 47 degrees. So there we go. We were able to solve that, and we got the 47 right here, which means we can get that top angle up top using the angle sum theorem. That's 28 degrees. And then we can get side C, which is right here, by using the law of sine, or if you like the law of cosine, you could do that, but I think the law of sine is easier. So I'm going to just put the answer up top here. You can double check that, and we get 35.5. So in example A, we didn't have any triangles that you could build. In example B, we got one. And now we're going to get to the next example, which is my favorite. All right, so I've drawn it and can see that again we have side-side angle or angle side-side, and we have an acute angle. So with acute angles, I am going to just, that this C to B, maybe it angles down, maybe it goes straight down. So what I'm going to do is I'm going to draw in a dashed line right there, and I want to know what the height is, because if that height is 8, then C didn't angle down to B, it went straight down to B. So let's go ahead and figure out what that is using trigonometry. So I figured what H is, and what's different this time from example 3A is my height ends up being 6.2. So I know that C didn't go straight down perpendicular to AB. It had to angle over. So when that third side is bigger than the 6.2, but it's smaller than the 8, that means that you can angle down going to the right, or you can angle down going to the left. So I'm going to draw that in like so. So there are two triangles that you can construct. One is going to have an acute angle, and I'm going to put that as B1, and then I could also have a B2, and right there is going to be an obtuse angle. So I'm going to redraw this. So I've redrawn this over here, showing that there's that H going right down the middle, and right here is that isosceles triangle. Okay, so again, I hope that you watched that video on the ambiguous case. This is an interesting case where I can build two different triangles. So yes, I am going to use law of sines. Just one of the angles is going to be acute, and the other one over there is going to be obtuse, and that's really going to be the difference. And based on how big angle B1 or B2 is going to dictate how big angle C is, which can be either of those case scenarios. So this is obviously more work, but the process is going to be the same of finding the missing sides and angles. So I've set up my proportion, and I'm solving for an angle. So I get sine of angle B, and I'm going to shave some steps here because we're running out of room here, and I get 0.76957. So I did the cross product, and then I isolated the sine of B. I'm getting a good ratio that's between -1 and 1. So I'm going to solve for angle B using the inverse like I did in the prior two cases. And angle B is approximately equal to 50 degrees. So did I solve for the obtuse angle? Did I solve for the acute angle? Because it's 50 degrees, I definitely solved for the acute angle. So that was solving for B1. So to get angle B2, this is really easy. Because B1, and let me do that, is the same as that angle right there because it's isosceles, then B2 and B1 are going to be supplementary because they form a linear pair. So B2 is going to equal 130 degrees. So as long as we understand that relationship, getting the angles is really quite easy. So now the last thing we have to do is get angle C. So again, I don't need to use either of the laws because I know two of the angles. I can get the third angle. So let me fix that here. So based on B1 being 50, then angle C ends up being 92 degrees using the triangle sum theorem. And then side C ends up being 13. Now again, you could use law of sine, law of cosine to get that. When I go to angle B2, if that is 130 degrees, then angle C ends up being 12 degrees, and its opposite side C ends up being 2.7. So that's why we call it the ambiguous case, because just because we have SSA or ASS, we don't know what the outcome is going to be, whether we can construct two triangles, one triangle, or if it's not possible at all. So I hope that this made sense by watching the 3 videos. In class on Monday, we're going to discuss any questions that you had. We're going to reinforce this. So if you want to get started on the homework, you feel comfortable with it, great. Otherwise, I will see you Monday in class, and we will reinforce the law of sines and the ambiguous case. See you then.